So we're going to do this proof, but even those words made it hard to see if or what the situation was. So I would like to share my screen and build the graph so that we can know exactly what we're talking about. So I start with a really generic function. Instead of starting with the one you started with, I started with a general one. And notice if n gets smaller, this thing gets wider. If n gets bigger, it gets skinnier. So let's go here, and by conics theory, P is 1 over 4 times this coefficient. So here's P, and the focus is at 0P, and the directrix is at y equals negative P. And notice, if I change n and make it smaller, these spread out. And if I make n bigger, the focus and the directrix get closer and closer together toward the vertex. So let's make it something we can work with. How about let's go here. Now, we need to pick a point, and I am not going to use x1, x0, x2. It's too many x's to keep track of. I am going to call the point on the right side of the parabola B, and I'm going to label it. Now, B can change, and I think it would be better if I made it a little bit bigger. Now, I need the tangent line from B to the directrix. And so that's just doing the y value at this point is f of B. And so here's the tangent line. And notice that it intersects the directrix here. Now, you called that x1 negative P, but I'm going to call it A negative P. So here's the point where they meet. And now the only way to make this work is if what you use for point C has its tangent line also go through A negative P. So you have to set that up very carefully, and we'll talk about it over on the board. But after you do all this math and rearrange things, here's my point C, and its tangent line is y minus the y coordinate of this, which is f of C, is the slope, which is the derivative at C, times x minus C. And notice they intersect right here at A negative P. So that's the situation you have, and what you're trying to prove is that the segment from, oh, this is point C, from point C here to point B here is going to go through the focus. And so here's the slope. It's y2 minus y1 over x2 minus x1. And then here's the line between them. And notice it does go through the focus. Now that takes a lot of calculations. So I want to make this so that it'll show up well. Let's see if that works. And let's put this on our graph. It's not going to work like that. I think I might want B to be bigger. I think I want it to be smaller. Now I think they won't get confused. Well, here's point C, here's point B, here's the focus, and here's where they meet. Okay, we'll keep this. Okay, so now we need to go back to here, and I want that picture. And we're going to need to shrink it a little bit. Okay. Now, just like you know, if I let y equal nx squared, then my derivative or my slope of the tangent line is 2n times x. So this tangent line is 2n. Well, this x coordinate is b. And this purple tangent line, it has a slope, which is 2n, and this x is point C. The x value is C. Now, we also know that point B here has to pass through a negative P. So another way to come up with the slope is to go B, f of B, that's the point right here. It has to pass through here, and it must also pass through a negative P. And so that has a slope of y2. I'm going to start here. y2 minus y1, and that's divided by x2 minus x1. And so the slope of the green line, the one on the right, is f of b, which is the y value at b. So this point is at b, and if you plug in b, you get the y value is nb squared. And up here, if you plug in c, you find that the y value is nc squared. Okay, so this is f of b, which is nb squared, minus a negative makes this plus p, and that's over b minus a. Now, this slope and this slope must be the same because they're describing the same line. And so I can set these two slopes equal to each other and have that 2nb equals nb squared plus p over b minus a. Now, to figure out a, you need to solve this. To figure out what this x value is, you need to solve this for a. So, if you solve this for a, you get that a equals let me see if I can find it so we don't have to start from scratch. Here it is. A equals b minus nb squared plus p all over 2nb. Okay, now go through that whole thing again over here with the 2 points. A negative P, and now do it for C, and C NC squared. And so this slope is going to end up being NC squared minus a negative P over B minus A. And again, this needs to equal the slope that you get when you for the tangent line. Now, the whole rest of this hinges on solving one of these equations for either P or A or C or N. And in the end, let's remember that N is 1 over 4P. And so we can put it all back in P's if we really want to. Now, we solve this for A, and then we can use that A over here to find out what C is. So once you choose B, you use it to find A, and then you use this expression for A here, and you can solve for C. So if we solve this for C, it's a whole different ball game, because you have to cross multiply. And so we have that NC squared plus P equals 2NC times C minus A. Now, distribute this, and we have NC squared plus P equals 2NC squared minus 2ANC. Now, I want everything on one side, because this is going to be a quadratic equation in C's. Here's the coefficient for C squared. Here's the coefficient for C, and this is a constant. So if I subtract NC squared and I subtract P, I end up with 0 is, well, 2NC squared minus 1NC squared gives me a single NC squared minus 2AN times C minus P. And then you use the quadratic formula, minus B plus and minus the square root of B squared minus 4AC, to find out that C is actually A plus or minus the square root of N times N A squared plus P all over N. And if we needed to find C in terms of B, we could plug this in. But we're not going to do that right now, but this is how we're going to find the x-coordinate of this other point that we have to choose so carefully in order to make it go through A negative P, so that we have our intersection right here on the directrix. So if you use that, then you can write the equation, and you find out that this does pass through here. So that's the purple line. And so now you can write the equation for this chord. So let's go to a new page. So that chord from B to C has a slope. Let's do it in black because it's in black on the other page. So its slope of our chord now is f of B minus f of C over B minus C. And so let's use, say, the point C. So we're going to use this slope and the point C, NC squared, and this is going to become NB squared minus NC squared over B minus C. And notice you can factor out an N, and then you have B squared minus C squared, which I hope you recognize as being factorable into B, well, so this equals N times B minus C times B plus C all over B minus C. So these cancel, and it turns out that the slope of the chord that we need to use is N times B plus C. That's it. So now we write this equation. So we have y minus nc squared, y2, y minus y1 equals the slope times x minus x1, which for us is c. So if you distribute this in, and then you FOIL this, you get y minus nc squared equals NB plus NC. This is times X minus NB plus C times C. So I took all of this times X, and then I took all of this times C. And here's the minus sign. So now I have y equals NC squared equals NB plus NC times X. That's my slope. But this is now minus NBC. So this and this plus NC squared. That's this and this. So distribute the minus sign. This should just say minus. So distribute the minus sign over here and get y minus nc squared equals, this is the slope, times x, then minus NBC minus NC squared. So if you would add NC squared to both sides, these would go away. And in the end, that chord, it's given by the equation y equals NB plus NC times X minus NBC. Now, to prove that it passes through the focus is at 0p. And so we're going to let x equal 0. And if we can show that y equals p, we will have proved it. So if x is 0, then y is just negative n times b times c. Now, here's where rearranging all that stuff to be in terms of p's is very helpful. So let's start on another new board. If y equals negative n times b times c, first of all, we know that n is 1 over 4p. But we never, back here on board 1, we solved for a. We could have solved for b in terms of p. So if we go back to here, come back to here, and instead solve this for p, it turns out, or solve this for b in terms of p, you get another quadratic equation with b as your variable, and it turns out that b is a plus the square root of a squared. You'll have to do all the other steps. This is already taking too long. But it turns out to be this. That b, in terms of this point, and p is this, and you can do the same thing solving this. If you solve it for c in terms of a and p, you find out that this c is a minus the square root of a squared plus 4p squared. So now we're going to come back over here and substitute this stuff in. So I have y equals negative 1 over 4p, and b was a plus the square root of a squared plus 4p, and c was a minus the square root of a squared plus 4p. Now, when you FOIL these, what you get is a squared. This FOIL cancels, and then you have minus a squared. Oh, these should have all been squared, shouldn't they? Make sure. Yeah, those are squared. A squared. So you multiply these, you get a squared plus 4p squared. So distribute the minus sign and get that y is negative 1 over 4p. And then this is a squared minus a squared minus 4p squared. So these cancel, and you end up with y is minus 1 over 4p, but then it's multiplied by minus 4p squared. So the minuses cancel, the 4's cancel, and 1p cancels, and you get that y equals p. Therefore, the segment from B to C passes through the focus, which is at 0p. And we've proved it.